All right, we're kind of on a roll here, guys, with no pre-lesson. Everything's just kind of combining together, all your lessons from previous days. And so let's just dive in. See, this is day 2 of 3-2, so it is connected to our previous day's lesson. But pretty major difference. This is going to be more challenging because you have a lot more work to do. Look at this. It says step 1, find the x-intercepts. Now, when they're written like this, like they were in the previous day's assignment, it is a piece of cake to say, 0, -2, 3. You see, not going to be as easy for this. So hopefully that triggers what you need to do next. You got to find these. Uh-oh, how? Well, if it's factorable, you should factor it. But that doesn't look factorable. It's not a trinomial. So this is why you learned plus or minus p over q. This is going to find your rational roots. What's your roots? Your zeros. So here we go. 6 plus or minus 1 plus or minus 2. Do I hear groaning out there? I thought I did. All right, but that's only over 1, so that's good news. There's no other way of getting it but just plugging and chugging. So that's 1. 1 squared is 1 times minus 4 is minus 4 plus 1 plus 6. Too many positives. Let's try -1. -1 cubed is -1. -1 squared is 1 times -4 is -4. Minus 1 plus 6. Nice. So there's a 0. So we're excited about that. Here's one of our zeros. But you can see we need 3. So we're not done. What do we do with that? We put it in the chipmunk nest. And so now we take the coefficients. 1, -4, 1, 6. Drop the 1, multiply, add, multiply, add, multiply, add. We love it when that's a 0 because that means we're doing our work correctly. Well, what does this really translate into? Remember, when that was a 3 originally, we reduced it to a 2. So this is x squared minus 5x plus 6 equals 0. And look at this one. How nice. So this one factors into -3, -2. So I get 3 or 2 as my other zeros. So here's 1, 2, 3 zeros. Now we're ready to rock and roll. So -1 would be right here. 2 would be right here on the number line. And let's just put 3 out here. Are they spaced perfectly? No. But that's not really the big deal right now. So we know this is a cubic. And we know A is positive right off the bat. So generally speaking, it's going to look like this. And because this would technically be written as x plus 1, x minus 3, x minus 2, you see less than or equal to 0, because that's what this really factors into. We know that this is odd multiplicity, odd, odd. So that means it doesn't bounce off any of these. So because of this, I know it's going to go up to the right from there, down to the left from there, and it goes through all of these, so it goes like this, ish. But what does this say? You have to pay so close attention to this. Less than or equal to 0. That's where it is right here too. So what does that mean? Under the graph and include the zeros. That would be from here to here. So that'd be negative infinity, parentheses, because you can't reach it, all the way up to -1, bracket, because it wants the actual 0. That's what the less than or equals means. Together with, and then we need to describe that space from 2 to 3. And there it is. There's your solution of that crazy problem. Okay? And here we go with this one. So again, we have another cubic, and we know A is positive right off the bat, which means it's going to look like this again. And now we just need to start factoring this, which means you got to start with your plus or minus p all over q. You got to start here. So that's 1, 2, 3, 6. A little bit of a bummer. We got a 2 there. Remember, when this is a 1, if we were to put it all over 1, it wouldn't change any of these. But because that's a 2, it doubles up the number of possibilities because we got plus or minus 1, and then we got plus or minus 2. Now I said doubles, but you'll see what I mean in a minute. So if I only concentrate on these, that would give me plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. But then if I concentrate on this, that would be a new one, plus or minus 1/2. If I go 2 over 2, that's just going to give me my 1 back, so I don't have to worry about that. 3 over 2, that's new. And then 6 over 2 just gives me my 3. So really, these are my possibilities. And I say a little prayer, and I hope that 1 works. 1 cubed times 2 is 2. 1 times 3 is 3. Minus 11 minus 6. Not a chance. Negative 1. Negative 1 cubed is negative 1 times 2 is negative 2. Negative 1 squared is 1 times 3 is 3. Negative 1 times that is 11 minus 6. So that's negative 8 and 14. Didn't work. Oh, I hope it's not a fraction. 2 cubed is 8 times 2 is 16. That'd be 4 times 3 is 12. Minus 22 minus 6. Praise hallelujah. Look at 28, negative 28. There it is. Once you get started, now it's easy. So there's one of my zeros. Put it in the cheap monk nest. 2, 3, negative 11, negative 6. Little shout out to Ian Rodriguez right now, flying in those big birds for the Air Force. Put it in the cheap monk nest. All right. Drop the 2. 2, 4, 7, 14, 3. That'd be positive 6. Add, we get 0. Now watch this, you guys. This turns into 2x squared plus 7x plus 3 equals 0. Now, you guys haven't factored a ton of these lately, but we're just going to dive right in, use a little trial and error, but this one's not that bad. See, I need 7x when I'm done, so I'm going to put the 3. So I know this is going to be 3 and 1. I'm going to put the 3 on the outside and the 1 on the inside because I want 6x and 1x is 7x. And they're all positive, so I don't have to worry about that. And then I look at this and I go, aha, take the opposite of that, negative 1, divide by that, 2. And then this is obvious, just negative 3. So here's a 0, here's a 0, here's a 0. Again, I don't want to confuse you, but to figure out whether it bounces or goes through, I would write this if I was asked to, 2x plus 1, x plus 3, and again, that the original is greater than 0, which means this is a 1, that's a 1, that's a 1, which means it goes through all of these zeros. And so let's put these in chronological order. There's my negative 3. There's my negative 1/2, and there's my 2. And again, we already concluded earlier that it's going to look like this with a big old ish. So I know that's true. And because these are 1s, I know they go right through these zeros. And there's the graph, generally speaking. What's the original problem ask me to consider? Where does all this stuff go above the x-axis, which means positive, which means above the x-axis? Well, that'd be right here and here. But remember, it's not greater than or equal to, so it does not include the negative 3 and it does not include the negative 2. So that'd be negative 3. Oh, I said negative 2. I meant negative 1/2. And then it also goes from 2 up, but don't include the 2. So that'd be parentheses 2 all the way. I said up. It's really saying that way. Infinity. Okay? That's it, you guys, I think. Yep, that's it.